Whenever you're able to model a real-world situation with geometry, either on paper, like in a drafting situation, or on a computer using AutoCAD or some other programming system to model with geometry, then you're able to predict what will happen in a real-life situation before you actually go to construction. This lets you design, whether it be a skyscraper or an airplane. One thing that you may design for is efficiency. By creating a geometric model of the cross-section of an airplane wing, you can design it to be as efficient as possible, to give you the most lift and the least drag. Or, a more everyday example, by creating a geometric model of a soup can, you can create it to be as efficient as possible, to use the least amount of material, metal, and still probably create enough room for you to advertise on it. Another thing to design for is beauty. There's a lot of symmetry involved in this type of design. An example would be to creating fonts for typesetting. Now, in the old days, they probably whittled these out of wood or iron. Now we like to be able to create them in such a way that they can be scaled. Like this lowercase r, once I have a geometric model for exactly how I want my printer to interpret that computer image, I can scale it at any size. And one more thing that you can design for, once you have the power of geometry working for you, would be safety. This often is referred to as designing the operating limits of some construction. For instance, a skyscraper needs to be designed so that it can withstand a certain amount of wind pressure at the top, or a certain amount of earthquake pressure at the bottom. Another design of operating limit would be the material that goes on the front of a spaceship or shuttle so that it can withstand the temperatures of re-entry. You need to be able to design it so that you know from the geometric model of the re-entry how hot that nose is going to get and what material is going to be necessary to withstand the temperatures.